Now the next question is Csir Net Mathematical Science. Question from ordinary differential equation. Basically the question from green function. This is boundary value problem. And how to solve green function, how to solve particular integral of a second order differential equation by green function. We discuss here and solve this problem. Now this question is given that consider the boundary value problem u double dash equal to f, where u of 0 equal to u double dash 1 equal to 0, 1, 0, 1, and assume fx is real valued continuous function on 0, 1. Then g of xi, this is the green function, is given that x 0 less equal to x less equal to xi, and xi for xi less equal to x less equal to 1. And option B, both g and del g del x are continuous on 0, 1 cross 0, 1 with del 2g del x2 having discontinuity along x equal to xi. And option C, g x xi satisfy homogeneous equation u double dash equal to 0. And option D, the solution ux is given that 0 to x xi fx dxi plus x to 1 x f xi dxi, right? So the solution here, what is given? Given that u double dash equal to f, so the homogeneous equation, so what is ux? c1x plus c2. Now the condition is u0 equal to 0 and u double dash 1 equal to 0. Apply u0 equal to 0, then what we will get? u0 equal to 0, right? So 0 equal to c2, so ux equal to c1x. So what is y1? y1 equal to x, right? Now u double dash 1 equal to 0, so c1 equal to 0, so ux u double dash u dash x equal to c1 u double dash x equal to 0. So here we could not get anything. So what is y2? We consider y2 equal to 1, right? So here x is y1 and this is coefficient 1, so this is y2. Now what is green function for boundary value problem? D of x, here xi is replaced by t, so minus y1t y2x by Wronskian of y1 y2 for 0, here this is 0, so 0 less equal to x less equal to t, and 0 less equal to t less equal to x, and x less equal to t less equal to at the last boundary condition at the point 1, so 1, and y2x y1t by w y1 y2, right? So we get t and xi. The Wronskian is, what is Wronskian is 1, right? Sorry, Wronskian is minus 1 here. T less equal to x and x less equal to t less equal to 1. So if we choose y1 equal to 1 and y2 equal to x, then Wronskian is given 1. So this is minus 1 and 1 could not matter. So this is the green function. So option A is correct, right? And second option is, we know that del g del x has jumped in discontinuity at s equal to xi. for x equal to t, right? So del g del x are jump discontinuity. This is del g del x to xi plus minus del g del x equal to xi minus equal to minus 1 by a0 x. a0 means the coefficient of y double dash. This is 1. So minus 1. So del g del x has jumped on discontinuity as s equal to xi. So option B is wrong because we are given that del g del x are continuous, not continuous, are jump discontinuity at s equal to xi, and gxi satisfy homogeneous equation. This is obviously right because gxi, suppose gxi, this is g1 xi and this is g2 xi, right? For this condition 0 less equal to x less equal to xi, less equal to xi less equal to x, and x xi less equal to 1, right? Suppose this, then notice that g1 xi satisfy the left boundary condition. This satisfy the left boundary condition, this satisfy the right boundary condition. So both g satisfy the homogeneous equation u double dash equal to 0. Now the d, this is the general solution. Which is general solution? This is integration a to b at 0 to 1 g of xi into u of xi dxi, right? So what we will given 0 to x, yeah, the interval 0 to x and x to 1. So 0 to x g of xi divide f, sorry, this is u xi, sorry, here this is not u, here given that this is f, so that is f xi actually, and f xi dxi plus integration 0 to 1 g of xi f xi dxi x to 1. So option, I put the value g of xi is, what is g of xi? This is g of xi, what is this? This is actually xi, and this is from x to 1, this is here x, right? So option D is also correct. So A, C and D is correct.